Good morning, sir. So maybe this is here is the last recordings I will send. Thank you for everything. This is my explanation for the project of Deep Web Researcher. At first, we can go to the subject analyzer module. So these are the services available in here. We are using Tavily client, extractor, DeepSeek client, and subject analyzer. First, let's see what the DeepSeek client does. These this just sets up the DeepSeek API to chat with our LLM and get the response. These are all the parameters for the LLM, and this is the response we get as a JSON format. And after that, we go into the subject analyzer service. This performs analysis of given text by identifying its main subject and temporal context and topics to be researched. It uses the language model via the LLM client like DeepSeek client I just shown you. Then it gets the temporal context here and rewrites the prompt to be specified with the time, and then applies to the LLM again, and then it analyzes the whole thing to get the main subject, temporal context, and what needs to be researched. Then we come into the Tavily client. This Tavily client is for searching the web through Tavily API. Tavily API's settings are given here. The max result, topic, search depth, all the inputs are taken here, and then it searches the web and returns the results. Then another endpoint from Tavily is Tavily extractor. Tavily extractor is used to extract the data relevant to our query from the website, given websites. So the websites it gets from the Tavily uh, client. I just shown you this just before this. It gets the web URLs from there, and it extracts data from those URLs using this Tavily extractor. It can also include images if available. And then comes the subject analyzer. I shown you all already. After that, there is analysis models. This analysis model sets up the class structure for everything. The subject analysis for class gets the main subject, what needs to be researched, and temporal context and the data types. And here are the analysis config for LLM, and this is for results. The subject analysis results, analysis config, the actual result, the confidence score for each one, and the timestamp. And if we come outside the subject analyzer, we will see the web agent. The web agent does with the web search service is provides a service layer that wraps a generic search client, standardizing the search queries and returning results. It serves as a bridge between the subject analysis and search operations. As you can see, here are different classes for the web search service, which sets up the structure for the web searching rather than the LLM only. The previous parts only deal with the LLM parts, and this one is setting up the query structure and results, how it will get those for the web service, including web search and web extraction. Both the let me show you again the web search service here. This accepts a search client such as Tavily and search configuration, and they initialize the console for the output. And the method search subject here, this iterates over a list of additional aspects related to the main subject as we got from the subject analyzer, and then constructs the separate queries for each aspect, aggregates the results in a dictionary to search through the Tavily API again. So the execution role is after analyzing the subject, this service is used to look up more detailed or additional information from the web to support deeper research. Then we have the search models here. So search model does it defines data models for representing web search results and configurations. These models help to standardize how result data is stored and exchanged between components. Like there is a search config, it defines the search configurations with the active results for page, for results for aspect and aspects, aspect search results. So search result is represents a single result using the URL, title, content, relevance code, etc. And this is the aspect search results. This is the group search results per aspect, totals, and an average relevance score. This provides the structure for search response data and parameters used by the web search service. Then comes our main file for the whole project. This is the researcher.py. So this acts as the high-level interactive web agent and a subject analyzer. Basically, this is our deep web researcher. This file ties together all other components I just shown before to perform the entire research workflow. So from local file, it can also accept a local file from user if they want to give one. So from local file extraction, subject analysis, web search, user input, sorry, local file user input, then local file extraction, then subject analysis, then web search, content extraction, final report generation. So it does all this, and so it supports asynchronous operations to full content aggregation and retrieval augmented generations using Superbase. I use Superbase as our DeepSeek R1 doesn't have such long context window to go through all the search results at once. So it uses a vector search for the summarization. These are the imports, and this is the logic for extracting text from file. It first checks it's a PDF file or any other. If it is PDF, then it extracts using the PyPDF tool, and if it is docs, then uses the docx library. Returns an error if neither is found, and if it is CSV, it uses pandas to get the data. Same with import fields, and if if it doesn't get a file or the file is something else, then it uh, throws a warning that could not extract the file, and file extraction error, throws into the log. I'll show you the log file later. So here is the research task class. So this represents a single research task with properties such as original query, current query, which can be refined based on feedback, analysis results, search results, and extracted content. So this is the print debug info, prints the structured debug messages, and update feedback is to store users' feedback to refine the query. Then it analyzes using the subject analyzer we defined earlier to analyze the query, augmenting with the current date, and prints the details about the object, temporal context, and users' reactions. Logs the success or errors. Then is the search and extract function. This goes for each topic, like main subject and additional research topics, constructed details queries, and calls the web search service to search, filtering out URLs, DOM it, and uses this Tavily extractor to extract content from the resulting URLs from the web search service. Truncates the extra long content to focus on it. I did that to ensure that the starting and ending headers and footers are not included in the search results. which are just random HTML parts. Then there is analyze full content wrap. Then it aggregates all the extracted content from all topics and created text chunks. Uses OpenAI's embedding API. This is here. Create embeddings for the text got from the search results, and it connects to the Superbase database and it inserts all the chunks generated to the Superbase database. Then there are constructs a summarization prompt, include the aggregated content and citations, and sends it to the DeepSeek client for secondary comprehensive analysis, and executes a store procedure match chunks to retrieve the most relevant content chunks. This match chunks is defined in the Superbase only. This is the part for summarizing the search results. And this part is for generating report research that too dynamically. This is the generate report method. Here. That's the original query, and in context to the date, time, and the current query, which is the refined one. So then it passes the agent's understanding, which we got from the subject analyzer. Then generates the report in a markdown format using the topics, the URLs, and the reports, the summarization report generated by the DeepSeek API. It also gives citations at the end to help understand that the facts mentioned in the report are true to the web search facts. This generates summary report. This one generates. This one is for the whole report. This one generates the summary report, and this is for saving the reports for both full and summary. The full report is like goes up to pages and pages, over 50 pages. So we are also generating a summary page to give it to the user to help him understand it better. So the save reports function writes the full and summary reports to files based on file name derived from the original query. It automatically derives the file name for the user's query and saves the file. So the main function here is it loads the .env file to pass the environment variables, and then there is the search config for search parameters, the analysis config for LLM and analysis parameters like model name and temperature, etc. Instantiate service clients, DeepSeek client, and Tavily client, Tavily extractor, research service, and research analyzer. We also shown this earlier. And then there is the user input section. There is the research query entered, then it uh, gets the no query provided, then it exists if no query is provided, and after entering the research query, it's asked to enter URLs if user have any specific URL in mind to research about. You also asked to enter URLs to omit from the search results if user wants. Then ask for a local file if user have some to enter his own files. And after that, just ask for the search depth for basic or advanced. The default is advanced to go into more depth to the URLs. Like if a URL contains multiple pages or uh, a page of that URL contains another URL, it goes into those. Tavily handles all those. And this is the search breadth. This is the results per query we want to search for or extract from. So by default is 10. We can enter anything from any number of values. This creates a research task class to perform the subject analysis. There is a feedback loop until user says agrees on the subject analysis results. User can keep giving feedback. This is for not including the URLs and filters the URLs, and this generates the report and with citations with the analyze full content drag function with the DeepSeek client. And then it saves the full and summary report, markdown files, and they are saved. And our research ends like this. One of the outputs, the query was analyzed as the stock, this, and this is the research report including the think tokens. So this is the point. These are the points the agent came up with, which it should include in the report. And this is the actual report generated. This is the Tesla TSLA comprehensive business report. And here you can see it writes the report pretty good. Using the URL drivers, multiple institutions which give projections for stocks. Also created a table with threats from Chinese automakers, data analysis, markets, and brief conclusion at the end. And these are the citations it used to generate the report. And you can see that this report is our final result. And there is another full report, which is this. These are many pages. These are all the data extracted from URLs and everything it got from research. So from this, it generates this summary report.